G'day. This is the second video in my series about creating a standalone network probe on an Esp32 microcontroller. This video looks at micropython coding for managing both an SD card and my logic for host and network tests. I think I'll need an SD card to hold the results of the network tests. So it'll be creating a large amount of data. So the rest of the video covers the code for managing those hosts and tests scheduling. And by the end, I should have everything I need for defining the hosts and the tests that I'll be scheduling. And should be able to do a trial run of the scheduler, do a test of the network tests, and just make sure all the parts are working.
So I added some code to detect if a SD card is present. So you see here in the main, I'm now setting up an SD card interface. Then I mount that SD card if it's there. If it's not there, then it throws an error, and in that case I set this global variable has SD card to false. So let's try it out. So first I'll run it without an SD card in the device. So it realized that there's no SD card there, so it's just used the onboard netconfig file, and that's set up to just use the .45 static address rather than DHCP. And let's put the SD card in the device. And let's try running it again. So that's good. Now we see that there's been a DHCP address assigned to it because the netconfig file on the SD card says use DHCP. And just a quick look at some of the things I had to do for this. So probably the trickiest thing was to set up the shared variable where I can set has SD card in main, and then other modules can make use of it. So the way I did that was I set up a shared Python file. So basically has SD card equals true in there, and then in main, the first thing main does is determines if it has an SD card. If it doesn't, then it then goes and sets that same variable shared has a SD card to false. And then other routines like the netconfig file, netconfig routine can then have a look, and we see here in the init it also imports the shared module, and it looks to see if shared has it SD card is true or false. If it's true, in which case it has an SD card, then it goes and sets the config file name to be the name that it would have on an SD card, so it has the SD card path appended to the front of it, and then everything else works just the same. So I'm going to start working on the hosts part of the netProbe. Okay, from the first video I was showing this diagram. So basically the hosts will be read by the test scheduler, decide what tests need to be run for what hosts. And just from my UI diagram, hosts kind of look like this, and it's going to, each host is going to have a unique ID as well as information about if and when a ping is performed, if and when a Bing is performed, and if and when a HTTP test is performed on that host. Okay, to store the host information, I'm going to use a JSON file again, so it's going to be called hosts.json. It's actually an array of host objects, and each host will have this information in it. It may change as I work on this, but basically has an address, which is a network reachable address, so either form of like Lupincorp.com, or it could be an IP address. Has a unique ID, has a description, and then for each of the types of tests, so for ping it has whether it's active or not and the interval minutes, Bing active or not, interval minutes, web active or not, interval minutes, and then additional information about what URL on that host it goes to, whether it should look for a matching string. If you just leave this blank, it'll not look for a string, or will always find a match, and whether the website is HTTPS or not. And some of these parameters you can leave out. So for example, down here where I wasn't doing a web test, I just left out that whole web information. So that's now for working with the hosts.json file. I created a hosts.py. So it's a hosts class in that, and this really follows the form of the netconfig.py file I showed in the first video. So by default, it calls out what the hosts.json file name would be during a init. If it finds that an SD card is present, then it adds or appends SD to the front of the host file name, so it will look for the host file on the SD card in that case. And during a init of the object, it'll do a get hosts. So in the get hosts, it'll first check whether that file is found, tell me if it's not. If it is, then it just does a JSON import of that host file into a Python object called self-host. So up here, this hosts property up here will hold the hosts object with all the hosts in it in Python format. And also it's going to run through that list of hosts and find out what the current maximum ID is, and that's what the set maximum ID does. It just runs through all the host objects and keeps track of what IDs are there and sets self max ID to whatever the greatest ID is at that time. So this Python module will do some additional things. I need to work on individual hosts as well as being up to update and change the host file around. So this little routine will just get a specific host based on being passed an ID and return that host object. And then these routines in here will be used to update the hosts file, and eventually I'm going to have a web service wrapper around here which will be talked to by the Angular UI, so I can do things like update host and just pass a new host object to it. So for the update hosts, because we already are working on a host that exists, what it does is it'll go and find the actual host that has the matching ID of the updated host object we're passing to it. So once we've found that host, it's going to remove that host from the array, our self hosts array. It's going to append the new host, and then it'll go through and recalculate the maximum ID. It probably doesn't really need to do that, but does it anyway, and then it writes out the new hosts JSON file from the self hosts file. So we always have the latest version of the host file saved onto that hosts JSON file. If we want to remove a host, we just pass an ID. Again, it'll run through all the hosts in that hosts array, and when it finds one, it'll remove that particular hosts. It'll reset the max ID, so if that host happened to be the one with the maximum ID, it recalculates based on what remaining hosts and host IDs are there, then writes out the hosts. And finally, for adding a new host, we just pass it a host object. So in this case, it works out what the next ID should be based on what the current max ID is. So it'll add 1 to the current max ID to work out what the host ID should be. Then I'll append that host to the list of hosts in the array of hosts and self hosts. Recalculate the max ID again, and write out the updated hosts file. And this little routine is the one that write out the host file. So it's looking at the self host object, Python object, does a JSON dump of that, so that converts it to a string, a JSON string, and then writes that out to the host file. Now to test the host functionality out, what I did is again in the main routine, after connecting to the network, I go and set up an instance of the hosts class. So hosts is the hosts object. And then first thing I do is, after doing that, it should have loaded in the host file if it's successful, so I print out what the current host's max ID is. Then I create a new host, so you see the format here. The only thing I do is I don't include an ID, because that gets set as part of adding a host. So I've got the new host I'm going to put into my hosts file there. I do a hosts add that new host, which should test out the add logic, and then I'm just going to print out host 4, because I know that my current maximum host is 3. This new one should be host 4, and then we can also have a look at it in on the actual device. So I've already transferred all the files over to the device. Let's run it. I'll do a hard reset. Let's pull that up a bit. And there we go. So we connected. It's got the connection address. So the max ID at the moment is 3. And then it added the new host, and here we see what it sees as being host 4 in the hosts.json file. And that looks right. So let's just do a look into the actual device and open the hosts.json. Let's pull that down now. I'll format the document. So here we see our hosts.json file we saw before, one with hosts 1, 2, 3, and the one I just added is now host ID 4. I also did the test for the remove and update host, so I'm fairly confident on that code at the moment. The next piece I need to work on is the scheduler for the host test, and this is the hosts array object that we just saw being created. So this is kind of how I think it's going to work at the moment, and bear in mind this is going to end up being a sync IO routine, so it needs to be able to pass back control to the main program, so that things like the web services microdot can get a look in as well. So I think for the scheduler service, it'll be one of these routines that wake up periodically, and the first thing it needs to do is get the last host tested. So probably out in hosts, I'll add another property called last hosts tested, where it keeps track of which host is being tested. And the thought here is I only do a set of tests for the host for each iteration of this routine, for a particular host for each iteration of this routine, so we're not holding it up too long. Remembering that the Bing tests can take 10-15 seconds to get through, so I don't want to do all the tests for, say, all the hosts and not give control back for microdot to get a look in, so I'm only going to do one host at a time. So we get the last host tested, and then we're going to have to run through and find out what the next host by ID number would be. So with that host, once we know which ones we're going to test, then we go and get the host test times. So this will be a new memory-based table of basically the host ID and last Bing, last ping, and last web times. And it'll also retrieve the test information, the things about, are we doing our Bing tests? What is the web URL that we're actually going to be testing for the web tests? So once I've got all of those, we'll check which ping, Bing, or web tests are scheduled to be run. So based on current time, what their frequency is, so they need to run every 5 minutes, and a particular Bing test hasn't run for 10 minutes, then it'll know, hey, I need to schedule that particular Bing test for that host. Once it's worked out that any tests for that host that are due to be run, we'll do the tests and record the results. Then after that, it's really just a matter of cleanup. So we update the host test times for the host. So any tests that we have done, we'll update this table with the last time those particular tests were tested for that host. We'll also update the last host tested value in here, so it's ready to go for the next iteration. And then we can sleep in this routine, which basically returns, for our async IO, returns control to other routines. So that's plan. Let's see how the coding's going to go. Okay, so having a look at the code that I added to the hosts library to do this. So I added a couple of new properties. Like I said in the design, last host tested by default is equal to 0, and this hosts tests, and note the plural there. I chop and change with the plural as I use this as the naming for the structure that's going to hold a record of when last tests were done for the various hosts, and that's just set up as an empty array. Then down here, these are all the hosts tests specific code, and the first thing to look at is now in init, as well as getting the hosts after I've retrieved the hosts information from the JSON file, I then call this build hosts test. So this should only be done once when this class is initialized, and that should only happen once when the netProbe is actually started up. So what this build host does is it makes sure that the hosts tests is still an empty array, and then goes through the hosts that we got from the JSON file, and for each host we go and add one of these entries to the hosts tests array here. So it creates a host singular tests, which has the ID of the host and the last ping, last bing, and the last web test times, which are by default 0 to start with, and appends that to the array of hosts tests. Other routines I've put in here, and these are called from outside the hosts class, is just get the host test, so get a singular set of information about a particular host when the last tests were done, so it returns a host singular tests here once it matches the ID. To update a host test, I basically do the same as I did for the update host, is runs through the host tests. When it identifies a particular host ID that matches the ID in the host that I want to update the test information for, then I remove that host entry from the array and append the updated host tests. And then the other interesting one is to get the next ID in the list of hosts tests. And for this, first I go and sort the array just in case the array is not in ID order. So I use the array sort function, and I call this routine to get the ID of the current host it's looking at, and I'll sort all the items in the hosts tests array in ID order. So once I know all those are in the correct order, then I say next found equals false, and then I go and look in hosts tests for a host test where the ID is greater than the last host tested. If it's found, then it just marks that as true and sets the last host tested to that ID and breaks out. If it didn't find anything, which usually means that we've come to the list of IDs and really we need to go back to 0, so in this case it just looks for any host tests where the ID is greater than 0, mark it as found if we find one, and sets the last host tested to that. Then finally, like I say, this is not really needed. I can't see this coming into play unless I've deleted all the hosts, which I don't know why the netProbe will be running without any hosts to test. So up in main, I've created the scheduler routine, and this will be set up as a sync IO routine that runs in the background. It basically continuously loops, but has a sleep at the end where it sleeps for a certain amount of time before it loops around again. and that sleep will also cause it to release control back to async IO so that other routines like microdot can run in the background. So let's have a look here. First we find out what the next host to test is, and that's where I call that find next host to test routine that we just looked at. And then I get the particular host information for that next host to test, which will have things about how to run the various tests and what tests are there for that host. And then I also return the host tests information for that particular host. So that tells me when that particular host, each of the tests were last performed. Now we go through, and for each of the type of tests we have, so first the ping tests, if the ping object exists in the host, it doesn't always have to. We don't have to do ping, bing, and web test for every single host. But if it does exist, then we go and create an object called ping, which is just a copy of that host ping object, and then check whether ping is currently active. So that's a true or false flag. So we can have the test in there, but we may make it inactive for a while. And then we do this conditional check on when it was last run. So if we look at host tests, so that has the information about when things were last run. So we get that value, which is seconds since the epoch. And then we look at the ping's interval minutes and multiply that by 60 to change it to seconds. So say it's every 5 minutes, then it'll be 300 seconds. So we add that to the last time it was run, and if it's still less than the current time, then it means it's due to be run. So if we fall into this routine, then it means we're due to run that ping test. Also, while we're here, we'll first update that last ping information to the current time, just to note that we're about to run it, and so that next time it comes through, it'll schedule properly. And then we'll do the actual ping. So like we saw before, we'll use the uping routine to do a ping for the host address, get the results, and here I'm just printing out the results. So in the next video I'll also put together how I'm going to actually log the results from all these tests, because there's going to be a lot of them. But at the moment, if the ping result's none, it says it's failed. If it was successful, then it prints out the results of that ping. And much the same sort of thing for these other tests. So if it's going to do a bing, it checks whether the bing object is present in the host information. If it is, and if the bing is active, then we check when it was last run, if it's due to be run again. If it is, then again we go and save the current time into the last bing time and do the bing test and check for the results. For the web, I found I had to do one other thing. I found if the web tries to do a test on a host that is down, it can hang up for about 60 seconds, which I didn't really want this sitting in a hung state for 60 seconds in case people are trying to use the web server and things. So I want to make sure it still releases control. So what I do is, still the standard thing, checking whether there is a web section for the host. If there is and the web test is active, then check if it's due to run, update the last web test time, and I'm going to do a ping before I go and do the web test just to make sure the host is there, so I'm not waiting for a non-existent host. So this is really, in this case, is just testing the host is there. If it returns anything other than none, then that the host has responded, and then we can attempt doing a web request. So we just build up the target based on the information in the web test object, do the web test, and which in this case print out the results. And then finally what I do here is I update the host tests with the host tests, so that's the information I've updated with the latest times that each of these tests were run for a particular host. So I update that entry so it's ready to go next time we come around, and then we print out the for testing here, I just print out what's in the host tests structure, so I can check that it's getting updated, and we can look at that when we do the test run. So I wanted to test things to see how it's going. So I set up a little Ubuntu Linux laptop. It was at 192.168.1.128, and on that I set up a TC command to set latency on it to 50 milliseconds. Also, I went to the switch that I was using for connecting to the Linux box, and I set the speed on the interface to 10 megabits per second. Now over in the code, I added another host to that Linux box running TC, so 192.168.1.128. I made it ID 1, so it gets tested first, and I'm doing a ping and a bing to that box as well. I've got 3 other tests to various hosts all over the place. This one here is kind of interesting. That goes out to New Zealand, so should be about a 200 millisecond round trip latency out there as well. So let's go up to main. I did change the scheduler routine now to have a sleep of 30 seconds. The reason I'm doing that is I'm going to loop through calling the scheduler 30 times, and what I want to see happen is after it's gone through a host and comes back up to look at that host again, if it's not ready to run the test, I want to make sure it doesn't run the test. So make sure that the host's tests last test times has been updated and been acted on to decide, hey, I don't need to run the test yet because it's not due yet. So let's run that. And open up. So I open up REPL and do a test run. So our round trip latency is coming in at 103 milliseconds, which is double the 50. And our Bing came in at 9 meg, close to the 10 meg that I've set the port for. So that's a good sign. Now I'm just going to let this run for probably about 30 minutes. Like I said, it's got 30 seconds now between each test, and we can watch the numbers getting filled in on this hosts tests here. So we just did this test ID 1, and you can see the ping and the Bing times have been filled in. Last web is still 0 because we didn't run our web tests. And now we're doing a test out to the my host New Zealand. Getting a 196 milliseconds round trip, which is about right. We're seeing about 65 megabits per second out to that website, and it's also done a web test, and you can see it's matched them up. And now we see test ID 2, which is the one we just did, has the new test times in it. So I'm just going to let this run, come back in about 30 minutes and see what the test looks like. But what I'm expecting is a second pass through these tests. They shouldn't be due to run the test, so it should just drop straight through those tests until either the 5 minutes or 10 minutes test schedule that I've put in so far has passed, and then I'll run the tests again. So let's see what happens. Okay, all the tests are run. Let's see what happened here. So we went through 30 iterations, probably took about 20 minutes or so to do that, and we've got different scheduling times for some of these tests. So let's just have a look at our JSON file again. So for example, Garden Home, I only do the web test every 10 minutes. For my New Zealand host, I only do the Bing test every 10 minutes. And the rest are all 5 minute interval. So let's see what this is looking like. Go back to the beginning. So there's our first test to our 128 address. New Zealand host tests, garden tests, and Lupin tests. Okay, so when things start up, all the tests get run for the first time. Then we saw it run through a few iterations here. It just printed out the host tests information, but didn't do any tests. And then when we get to iteration 8, then it comes in and starts doing tests again. For New Zealand hosts, just does the ping test is ready to do by the look of it. Garden home comes up, does the ping and the bing test. Lupincorp did all 3, and then just goes into sort of nothing's ready to test again for the next few iterations, and it comes up again and everything's getting tested again. So it looks like things are working like the it's not testing every test every time. It's using the last test times to work out whether it's ready to test things again based on the time that's passed since the last test and what the test frequency is. So I think this is good. So I think that's it for this video. Next one I'll look at reporting out the results of the tests to files, and a little bit more cleanup, and hopefully then the following video we can look at putting together some web services to get the results of these tests, update the hosts information, and then following on from that we'll get an Angular user interface in place so that we can manage and view the results of all the tests through a web interface.